Hey everyone, I am Diosa, a computer engineering student of University of Bohol, and today I will present my numerical methods project developed using a Python programming language. So this project is designed to solve mathematical problems numerically using root finding methods and matrix operations. This system allows users to input equation or matrices, then compute accurate solutions automatically. I developed this project using a Python programming language, a Streamlit for a graphical interface, Visual Studio Code for coding. So here's my Visual Studio. This is my code. And the GitHub for saving and managing the project files. So let's continue here. The project contains a root finding analysis and matrix operations. Here's the front in root finding analysis, and here's the front view of the matrix operations. So let's start in the root finding. So how I made this project. First, I planned the function and features I wanted to include in the system. I decided to add a root finding methods, a matrix operations, a graph plotting. So let's calculate this example. This is the graph plotting, the iteration table, which you can see the solutions, and how I handle any errors. Step 2 is installing these libraries, which is Streamlit, SimP, NumPy, and Matplot library, which help me to open this. So the purpose of each library is the SimP solves mathematical equations, the NumPy handles matrices and arrays, the Matplotlib library displays the graphs, which is this one. The Streamlit creates the graphical interface. Each function accepts equation inputs. Initial values is the initial values, tolerance, and the max iterations. So in we have 5 methods in here: the incremental method, bisection method, regular false method, Newton-Raphson method, and lastly the second method. Incremental method. This method searches intervals until a sign changes occurs. While the bisection, this produces tables and accurate roots. The Newton has highly accurate computation. So the function of this is it gives a highly accurate computation. And lastly, the second method. So this does not require derivatives. So let's have an example where we test our project. We have in the bottom part, we can see the equation examples. I already made an examples here. So let's start in a polynomial example. Let's copy paste here and delete this one. Let's choose an incremental and a negative 10 from the start and 10 for the end. The tolerance is, let's put 0.1. So max iteration, so let's add for 60. And the initial value is negative 10 and 0.5. Let's calculate the, so you can see we have root 1, which is 2.7. The primary root is negative 2.700. it only has two, two in iteration tables, which is negative 2.7 here. As you can see, it shows negative 2.7 in the last two root. So let's try for another method, the section method. And it adds up, but it only has one root. You can see that it changed from negative 2.7 to 2.6. In the bisection method, 2.60694. Negative 0.6094. Let's try another method, regular Folsen, and calculate this one. And now it changes over from 2.6 to 2.5. There's the 2.5936 is one. Other method, let's try another method. Let's try all the methods so we can see if it's already functioning. So we can see that it became 2.6 again, 2.602. By the way, we have each method has a different table. So you can see from the previous table, we have different function and formulas being used this kind of method. So let's move on for the second method. Just the two, it shows 2.5936. Let's try for another computation or an equation. Let's try this exponential. Let's see. Let's do a bisection method. Change it to 9. Let's keep on 10. Tolerance make the so as you can see, we only have one root found, and the primary root is 0.56640625. Using the bisection method, let's look here in the iteration table, and the last is 0.664. You can see the calculated 0.664. Let's try the incremental method. It only has one in the iteration table. 1. See 1. 0, 0. Let's also try in a binomial. Mm, value rounds. Let's change this into 0.7. You can see we have one root found. It shows the primary root is the negative 3.2. Negative 3.2. Let's change the incremental initial value. Make it into positive. Check if it changes. 1. You can see the Primary root is negative 3.050. The use of the incremental method, 3.05, as you can see. So we would test, lastly, we would test a mixed equation, which has an exponential and a sine. Mm, Let's try this one. It can solve a mixed equation. So you can see, we'll change this into 5 and 8. Tolerance is 1. It's 1. So you can see, the primary root is negative 3.05. Let's try another method. Still the same value, negative 3.05. Let's lower the scan step. So here's the front view of my root finding analysis. It shows that it can solve different kind of equations. And now let's continue in the matrix operations. We can add this. Here is the select operation. It has addition, multiplication, system of equation, adjoint, inverse, determinant, power matrix, transpose. So let's try 2 rows and 2 columns. Let's try a number 1, 2, 3, 4. 1, 2, 3, and 4. And the matrix V is 5, 6, 7, 8. 5, 6, 7, 8. So we will execute this matrix operation, and it shows it became, I already used an addition. So it is 6, 1 plus 5 is 6, 7 plus 3 is 10, and 6 plus 2 is 8, and 8 plus 4 is 12. So let's try multiplication. S- 7, 8, try. It became 19, 43, 22, and 15. Adjoint. So as you can see, it has 4, 3, negative 3, and negative 2, and 1. Inverse. It shows negative 2, 1.5, 1, negative 0.5. Determinant. The exact value is negative 2. power of matrix, 7, 15, 10, and 22. And lastly is the transpose. 1, 2, 3, 4. Say 1, 2, 3, 4. So it's just 1, 2, 3, 4. Let's try another number. 2, 1, 2, 1, 3, and 4. And the matrix B is 5, 2, 1, 3. 5, 2, 1, and 3. Let's try a multiplication. 5, 2, 1, and 3. So let's execute the matrix operation. It shows the given value is 11, 7, 19, and 18. So this how, it shows how matrix operation works. I'm sorry. In this part, you can see the history of what I've solved from incremental, from the root finding analysis to matrix operation. We can see the history in this part. We can also close. So this is my project in own language. The next part will be my Matlab project on how on how it shows solve using the Matlab. Thank you. Thank you so much for watching my video. I hope you learned something and you can use my project as a reference.
Hello everyone, today I will present my numerical methods project using Matlab. So in this project, it is designed to solve the root finding and matrix operations, same as my own language. It automatically using numerical methods and matrix computation. So in the system, it can find roots of equation, perform matrix calculation, display iteration tables, this one, and show accurate outputs quickly. Now, in the front page is I add the methods, which is incremental, bisection, regular false, mutant, and a second method. So you can see here, we can input the equation and A and B, the tolerance. So let's try to solve an example. Let's try and have this as an equation. And 1 and 3 and 0.1 for the tolerance. 1, 3.1 for the tolerance. So let's click the incremental first if it shows. As we can see, that 1.9 is in the roots and here in the last is 1.9. 1.9 to 2, same as in the graph. So let's try in another one. 2 and 3 and 0.01. 2, 2 and 3, 0.01. Let's try this one. It shows 2.7. The root is 2.7. Let's check here in the iteration table if it's 2.7. As we can see, it is 2.7 here. Let's try another method. Alright. Same as in the bisection, 2.7109. 2.721. Let's try regular false. 2.70. It shows 2.70 here and here. Let's try the Newton method. 2.70 and it shows 2.70. Lastly, the second method, same as the Newton, it shows 2.70. We can see that all methods work. So let's try for last one. Let's choose an incremental method and it shows the answer of this equation is 2.7. Let's check if it's 2.7 in the iteration table. And it is 2.7. So let's continue to the matrix operation. Let's close this tab and open the matrix solver. So here's the front page of the matrix operation solver. Before that, I forgot to let you view the code here. You can check my code in the GitHub. So let's continue to matrix operation solver. Let's try to run this. This one is the operations, the addition, multiply, inverse, determinant, adjoint, transpose, power, and we can solve this in here, the matrix A and B, the power n for power and an equation. And we can see here in the result, which we can calculate it. So let's try to solve. Let's try an addition here. Let's add 1, 4, and 7. This one is 2, 5, 8, 2, 5, and 8. One is 3, 6, and 9. 3, 6, and 9. B11. B is 9, 6, and 3. 9, 6, and 3. 8, 5, and 2. 8, 5, and 2. Lastly is 7, 4, and 1. 7, 4, and 1. Let's try an addition. If it's were. So it shows 10, same as the answer is given for my example, 10. So it calculates. Let's try another one. Multiply. Let's continue. 1, 2, 3, 4. Skip this. 0, 0, 0. And 5, 6, 7, 8. 5, 6, 7, and here is 8. And let's input 0 for the rest of the numbers. 0, 0, 0. So let's try to calculate if it's, and it shows 19, 22, 43, and 50. Same as the answer here and calculated already. 19, 22, 43, and 50. Let's try this one. Let's try determinant. 2, 1, 5, 3. 2, 1, 5, and 3, 0, 0. Let's try determinant 5, 1, 2, 1, 5, 3. Determinant. So shows 0. Let's calculate determinant. Shows 0, 0 value. And lastly, let's try the power n, the power 1, 2, 3, and 4. 2. Sorry for that. 1, 2, 3, and 4. Sometimes the Matlab online is gonna crash your project, so make sure to save first in order for you to save and to have your files even if it's crashing, especially when it has lower connection. There are some chances that it can crash your Matlab solver. So that's it. Let's try it last. I'll add some number 12, 20, 15, 8, 9, 5, 18, 25, 12, 14, 15, 26, 3, 1, 21, 30, 13, 24, and 29. So we will addition this if it's work. So you can see it functions the calculations. Let's try another one. Same as goes by in the multiplication. Inverse. Here is inverse. It shows a negative. The negative determinant. Adjoint. Here is the final answer in an adjoint. Transpose. And that would be all. Thank you for watching in this video. I hope you'll understand and that's all. I hope you and that would be all my numerical project and by Matlab.